Lesson 7.2, Day 2 is continuing to find the complex solutions of polynomial equations. And there's a fundamental theorem of algebra, which means that for every polynomial function, there is at least one zero, where zero, even though it may be a complex number, just means that you should have at least one zero for the polynomial. And let's do a quick review for the values of I. So if I equals the square root of -1, then I squared is actually equal to square root of -1 times square root of -1, which is -1. And then I cubed is just going to be I squared times I, and we know that I squared is -1 times I, so therefore it's just going to be -I. And I fourth is I squared times I squared, that's going to be -1 times -1, and that's how you get 1. So let's go ahead and apply that to simplify the first problem. And you want to isolate the -1 all the time. So it's going to be -1 times 4, and that is I times 2, which is 2I. And same thing here, it's going to be 28 times square root of -1. So that would be 4 times 7 times -1, which is going to be 2 radical 7, and then I just goes in between the two. So let's go ahead and solve our first problem, which is to apply -9 to both sides. So we have x squared equals -9. Taking the square root of both sides, we will have x squared. Actually, x equals square root of -9 is going to be 9 times -1. That will give us 3i, and we also have 3 plus or minus 3i, because whenever you take the square root in an equation, you need to apply the plus or minus. And so we're going to, now that we are warmed up for this lesson, we're going to be solving all of the roots for the polynomial function. The first one is actually in this form of a quadratic equation. So we actually can split up x to the 4th into x squared and x squared. The signs are going to be different. Two numbers that multiply to get 27, and the difference is 6 or 3 and 9. So we can see that this is a difference of squares, so we can split that into x plus 3, x minus 3, bringing down the previous term, the previous factor. We will have those 3 factors, and then we can actually solve these for that 0. So x squared equals -3, and we have x equals plus or minus the square root, taking the square root of both sides of -3, and then that's actually equal to -1 times 3. That would give us x equals plus or minus I radical 3. And then the other zeros are going to be x equals -3 and +3. So to continue, the list is going to be plus or minus 3 as well. So you have 4 roots total because the polynomial has x to the 4th. Next is b. We have 4 terms, which means we're going to use grouping, and we factor out the GCF. That's going to be x squared, x plus 3 plus factor out 9. We have x plus 3. So we have the common GCF of x plus 3, and then we have x squared plus 9. Solving both of these for the zeros, we have x equals -3 and x squared plus 9 equal to 0 will give us x squared equals -9, and taking the square root of both sides, we'll have x equals plus or minus 3i. And moving on to the next problem, we have a difference of 2 cubes. So this is actually 2x cubed minus 3 cubed. So we can factor this into 2 parentheses. We have 2x minus 3, square the first term, that would be 4x squared. Change the sign, multiply the 2 terms, we will have 6x, and square the last term will give us a plus 9. Solving these two for zeros, we're going to have x equals 2x minus 3 equal to 0, we have 2x equals 3 and x equals 3 over 2. And this one, we're going to need to, since we can't factor it anymore, we're going to need to use the quadratic formula, which is ABC. So negative b, that's negative 6, plus or minus b squared, that's 36, minus 4 times a, c, all over 2a. That's going to give us negative 6 plus or minus the square root of negative 108 over 8. And we can simplify negative 108 as 36 times 3 times negative 1. And that will give us negative 6 plus or minus 6i radical 3 over 8. There's a common factor of 2 in the 3 coefficients, so we're going to simplify by dividing by 2, and that'll give us negative 3 plus or minus 3i radical 3 over 4. So there are 2 roots here, plus the 1 here, that will be 3 roots together, and so that's the complete solution set. The next one, under triads, you need to pause the video and try the problems before you actually look at the solutions, because this is the triads. And so after you try it, we are going to do the problem. We can factor out an x, and then to solve to find the zeros in here, we're going to actually use synthetic division. So we set it up with other coefficients, and we're going to actually try 7s, because the factors of 91 are plus or minus 1, plus or minus 7, 13, and 91. So we're going to actually try 7. So bring down the 1, multiply, and we got negative 6, and here's negative 42, 13, and we have 91. That will give us a 0 and we will have the rest of the answer as x squared minus 6x plus 13. And since we can't factor this, we're also going to use the quadratic formula to find the solution. That's going to be ABC here. Negative 6 will give us a plus 6. And it's going to be negative 6 squared, which is 36, minus 4 times 1 times 13, all over 2a. So it's inside, we can simplify it to 36 minus 52 over 2. And that is actually 36 minus 52. That will be a negative 16. So we have square root of negative 16. So we actually have plus or minus 4i, because this is negative, this is 16 times negative 1. That's 4i over 2. Dividing by 2, we'll have 3 plus or minus 2i. And that's the solution coming out of this. And don't forget, we factored out the 7 earlier, so we will also have a 7 as the 0. So those are the zeros. And then actually we have 1 that we left off with the 1 that we factor out together. So when we have x by itself, the only solution you'll get is 0. So here is the complete list of solutions for this problem. The next one we have is actually in the form of difference of square. So we can see that this is x squared and x squared plus 4 and a minus 4. That will give us x to the 4th minus 16. And we will have x squared minus plus 4 equal to 0, and x squared minus 4 equal to 0, and you're going to get x equals negative 4, and the solution coming out of here will be plus or minus 2i, and then we have same thing, x equals plus or minus 2. So the full list of solution is going to be plus or minus 2i and plus or minus 2. That is the complete solution for those two. Next, we're going to go into the word problems. And in this problem, it's describing the shape of a cylinder with a hemisphere on top. So to the best of your ability, you need to draw a cylinder in the bottom with a hemisphere. That's half the sphere. So notice we are dealing with the volume here. So we need to bring back the formula for the volume. The volume of a hemisphere is going to be 1/2 the volume of an actual sphere, which is 4/3 pi r cubed. So that will give us 2/3 pi r cubed for the actual volume of the hemisphere. And then we have the volume of the cylinder, which is going to be pi r squared h. So let's describe the dimensions. The shape of the cylinder is a hemisphere, and then the height must be 3 inches longer than the radius. So if we let the radius be r, then that means the height is going to be r plus 3. So now we're going to set up the volume. It's going to be the volume of the hemisphere plus the volume of the cylinder. That will be 2/3 pi r cubed plus pi r squared times h, which is r plus 3. Simplifying everything, and actually we are given the volume of the composite figure, which is 72 pi. And simplify everything, we will have 72 pi equals 5/3 pi r cubed plus 3 pi r squared. And you need to probably do some math to distribute that and combine the like terms. So we will actually be entering these two equations as y1 and y2 into the decimals. And notice I've already done that. So there's my y1 and there's my y2. And then after graphing it, I choose the point where they intersect, which for the x coordinate, x is going to equal to 3. And so we know that the radius is going to equal to 3 inches. And that is the dimension for the radius. The next problem is for you to try, so you really need to again pause this video, try the problems first before you move on with the video. So go ahead and pause it. Now that you have tried the problem, let's go ahead and take a look at the solution. This one is describing again a composite figure with a cylinder part and a cone-shaped part on the top. So here is the cylinder part, and then we have a cone shape on top. So notice that the cylinder part is given with a height of 60 centimeter, and the height of the cone must be twice the radius. So if we let the radius be r, then the height of the cone must be 2r. So for the cone formula, the volume of a cone is 1/3 pi r squared h. And so for the total volume is going to be the volume of the cone plus the volume of the cylinder. And that's going to be 1/3 pi r squared h plus pi r squared h. So we will have actually a total volume, and we are given the volume is actually 558 pi, and volume of the cone is going to be 1/3 pi r squared. H is 2r because that is the given for the height of the cone, plus pi r squared. H is actually 60 for the cylinder that is given. And then again simplifying, we have everything. We will have 2/3 pi r cubed plus 60 pi r squared. And we will once again set this up in decimals, and notice I already have the two equations here, and this is where the two meet. So again, I have the radius is approximately 3. It's actually equal to 3 centimeters, and that will be the dimension, because the question is asking what should the dimension of the radius be. So the answer is 3 centimeters. And that is the last problem. The discussion problem, it says if after using synthetic division substitution to test all possible rational roots, you only find one root of the equation, can you conclude that the remaining roots are imaginary? So the answer would be yes. All other roots will be imaginary, since you have already tested all of the zeros using all the possible factors. And that's the end of today's lesson. I hope you have enjoyed this video.